Hello everyone, welcome to our Sentinel Hub webinar. My name is Sabina and I welcome you on behalf of our entire Sentinel Hub team. Today my colleague Monia Shabila will introduce the Bring Your Own Data functionality, which is available within the Sentinel Hub services. And after her presentation, the questions and answers section will follow. And now I give the word to Monia.
Hi everyone. So let's look at today's agenda. First, we will talk about what the Bring Your Own Data or the API is actually called Bring Your Own COG is and what kind of data qualifies. Then we will see how you can prepare your data for Sentinel Hub ingestion. We will show how to ingest data into Sentinel Hub using our dashboard. We will create a process API request to the collection we will create, and then we will also create a configuration and view data in your browser and also show how to integrate it with QGIS. So the Bring Your Own COG, what does this actually mean? So this API is intended for people to be able to import data that are not already part of the Sentinel Hub API. We hold a lot of collections already, but there are still so many outside available, such as, for example, several Copernicus collections, different kinds of commercial data. Actually, any kind of georeferenced raster data can be imported as long as it follows our constraints for ingestion into a Sentinel Hub. So the COG actually means Cloud Optimized GeoTIFF, and more in detail, you can see the definition written as well, is a GeoTIFF optimized for fetching a data subset at different resolutions. So what we need to do to import the data, it needs to follow the constraints that we have for this API, and also we need to convert it into COG. Currently, we support COG and ZAR, and in this webinar, we will focus only on the COG format. So for example, data examples of this could be different Copernicus services data, as already mentioned, as you can also see one of them on the image here on the right. There are several, for example, commercial data available. We will actually be using one such in this webinar. And also, for example, machine learning results are often so different than they need to be imported using this API. I would just like to mention that we also use this API all the time to import different collections. We have imported many, and you can also access a lot of them in our public collections repository, and there is also a DataCube collections repository where you can use those collections to access data yourself. The links will be in the YouTube description later on. So the general workflow that you have to go through to use this API is, first you need to check if your data is compatible with our COG constraints. Then you need to convert your data to COG using GDAL. Then you need to create an account on AWS to get access to S3 storage. You need to create a personal bucket on AWS. You also need to give it correct policy. Then you need to upload your COG files to the bucket. And then you are finally ready to create a collection and add tiles. You can do this in dashboard or using our API. In this webinar, we will be using the dashboard. And then you can create a process API request to the collection directly, or create a configuration and visualize data in your browser, QGIS, or another application. So before we begin, I would like to say a word about our documentation and about the constraints, and also about the data that we're going to be using. The data that we will be using in this webinar is Maxar data from Open Data Program. You can find it on maxar.com open data, and they have actually given a whole lot of disaster data available for free for research purposes, and you can just scroll down and then you will see several events for different years that you can freely download. If I open one of them, the one that we used, so the hurricane Iota over Nicaragua, we just clicked the preview. We checked the data, as you can see here. You can see the whole tile, the whole TIFF here, and then we just clicked download. You can do this yourself. Feel free to do so. Now we are going to jump to our documentation. and see where you can actually find more information about this API. So if you go to docs.sentinelhub.com, this is our technical documentation, you will find Bring Your Own Cog API here on the left. Here you have everything you need to know. And if you scroll down a bit, you will see the constraints that you need to know to successfully convert your TIFFs and other files to be compatible with Sentinel Hub. So these constraints are, some of them are for tiles, some of them are for bands, and some of them you can actually control, and some of them you cannot. So you cannot actually just upload any raster data. The data from the provider needs to generally be compatible with these constraints. For example, what you can control the projection. You can, for example, choose the compression and so forth. You can change the naming of your tiles. However, there are some, so how many bands you have in. Just check this yourself. There are several constraints, and we're going to also see how to do the process ourselves. Let's jump back and see what we need to do. First, we need to check if our data is actually compatible with our cog constraints. To do this, we will jump to QGIS, where we have the data inserted. Here I have the whole TIFF file without any modifications, the same one that we showed on the Maxar website before. And we can zoom in a bit, and you can see that this is a truly large file. We can see individual houses over here. We can see the waves crashing at the coast. And if we look around, you can also see some very large wildfires happening, such as, for example, here, and we can see individual trees. And now if we zoom out a little bit and we right-click and click Properties, you will be able to see in the information panel that this is indeed a very, very large file. You can see that the width is 41,000 pixels and the height is more than 250,000 pixels. Now this TIFF is huge, and to ingest it into Sentinel Hub, it needs to be retiled. This means that we need to dissect this TIFF into separate tiles so that they will be easily ingested into Sentinel Hub. You can find several informations in this panel, for example, the size. You can find which bands it includes and some statistics. So what are the values? This is going to be very useful for us when we will want to create an eval script to visualize them. And using this, we can already see that this data is in 8-bit unsigned integer. And so we can see that the maximum is 255. This means that it will probably be best for us to divide our bands by 255. We will see this later in action in the eval script. All right, so now if we scroll down, you can also see the coordinate reference system, and you can check if it is compatible, and yes, this one is okay. If we scroll down a bit, you will also see the bands, and here you will see the minimum and maximum, and you will see, interestingly, here we have a band 4. So what is this band 4? So if we zoom out a bit so that we can see the whole file, and then we go to properties, jump to transparency, we can see that band 4 is set to alpha. If we set it to none and exit, we should be able to see some black pixels here. None. I probably forgot to save the settings because it was hidden down below. Okay, and there we go. So this is what is inside, and this is how QGIS interprets Maxar's mask data. So this is something that Sentinel Hub currently does not support, and this is the specifics of this Maxar data that we had to handle to ingest it into Sentinel Hub. We had to remove it using a specific GDAL command that will be shown later. Sentinel Hub has its own way to handle this. So it has data masks, which are just the way that you tell the system which pixels are supposed to be no data, and then you can work with that and display them as transparent or any color that you like. We will also show how to handle this later. However, to actually then have a way to deal with this no data, we need to know what is actually no data value in this file. Then again, if we go to properties again, information, and scroll down, you will see that this band number 4 goes from 0 to 255. And now if we click on this information and we inspect a blank pixel that has no data, we can see that the value for band 1, band 2, and band 3 are actually 0. So this means that no data value for these 3 bands is 0. This is information that we need to remember. If we click on the pixel with the data, we can see several different values here, and this transparency band 4 has 255 because it only has 2 available values, either 0 or 255 when there is data available. Another thing that we will need to know, you need to be at least a bit familiar with your data that you are ingesting. You need to know which bands it has and how you would like to name them. So here we see that band 1 is red, band 2 is green, and band 3 is blue. We can use this later when we rename our bands in dashboard. Okay, so let's jump back to see what we need to do next. So the second step, after you have your data downloaded and you are sure that it is compatible with our COG constraints, you need to convert your data to COG using GDAL. And to do this, you have several commands available. So first, what you need to do is actually install GDAL on your computer. Well, there are several ways to do that, but the way I did it is I first installed Anaconda, then opened Anaconda command prompt, and then I ran a virtual environment with it. So Conda create and then the name of the environment, Conda activate it, and then install the GDAL version 3.1 or more into this environment. So you can also do this with older versions of GDAL, but it is highly recommended to do this using this version or higher, 3.1, because it creates better COGS, and it is generally just performs better. However, I had to do this using Conda Forge to actually install this higher version, and you can see the command here. You can also find some information about how to deal with older versions on our documentation. So the next thing that we had to do here, which is not necessary that you will have to do, is remove this internal TIFF mask that we talked about. So you know that those that displayed as band 4 in QGIS. We use this command to do so. And if you don't need to do this, you then just for most use cases, for smaller files, this command is going to work fine. If we jump to documentation, you can find the command up here. GDAL example command. So you just GDAL translate, then you use this compress deflate. This is just one way to compress, and it works well for most cases. Then you have to set the block size, and you also have some constraints. In our constraints, what you can set and what not. And then you just input here you input your input file and output file, and it's supposed to work. And then you also have overviews, ignore existing. So this just means that GDAL is going to create its own overviews for you. So we weren't just able to use this command and be done with it, because if you remember, our file was very large and it needed to be retiled. So instead, for a very large file, we use this command and we set the size that we want so that we lowered it a bit. And this command also did both. It retiled and also created a COG file. So I will now jump back to QGIS quickly, because I want to show you this retiled this tile. So for now we have been just watching the whole TIFF, but over here I have one of these tiles available, and you can see it down here. And if I turn both of them on, you can see that this is just one part of this large TIFF tile. Later, when we are in your browser, you will see this very clearly, because you will see the whole grid of them, and it will be even clearer what this retiling actually means. All right, so this command has created a whole bunch of tiles, specifically 3 times 13, and those then needed to be uploaded to AWS S3 console. So jumping back to our PowerPoint, we can see that the next step is to actually upload this data to AWS, create bucket and all that. So let's jump into it. This is the S3 console that I have over here. This is an outside service out of Sentinel Hub that you need to subscribe to. You need to create an account, and then you will host your data on here. So data that you upload to the OAS S3 bucket is not going to be hosted on Sentinel Hub. Sentinel Hub is just going to be reading from it. First, what we need to do is create a new bucket. Click on this orange Create Bucket button, and then give it a name. When giving it a name, you need to know that this name needs to be unique for all users, so not just for your S3 console, but you need to create something truly unique. So let's, for example, say Maxar disaster data new. And here AWS region, it is not trivial what you actually choose. Let's jump to our documentation and see what are the constraints here. Jumping to bucket region in the nav bar on the right, you can see that the region has to be either EU Central 1 when using EU Frankfurt, or US West 2 when using the US Oregon. So I'm going to select EU Central 1, and you can see it down here, EU Frankfurt, EU Central 1, and the Oregon is up here, US West Oregon. It is already selected, so I will just leave it as it is. When this is done, you can simply click Create Bucket. And the next thing that you will have to do, first you have to find it here, open it, and then set the permissions. So we have to set correct permissions, the correct bucket policy, so that Sentinel Hub will be able to actually read from your bucket and get data into Sentinel Hub. Let's jump back to the documentation, and here you can find the bucket settings under the bucket settings tab. We just copied this policy, paste it in here, click Edit, of course, so that you will be able to edit, and then let's replace it completely. Don't forget to replace the bucket name fields down below with the name of your bucket. We can just simply copy it, and also be careful not to copy over something that you should not copy over. Okay, I have accidentally copied in a space as well, but I think this should be okay now, and I will now save the changes. Okay, let me redo this. Might have copied something extra. Control C, and let's replace with that. Hope this works. Okay, so this is now our bucket. Going to objects, this is where you're going to upload your files. You will have to do this yourself. So as many tiles as you have, you will have to upload. In our case, we had a lot of tiles that were created from the large diff, and we had to upload all of them onto the bucket. Because this takes some time, I will not do this right now, but I will show you how this looks like in the bucket where I have already uploaded all the tiles. This is this one. And you can see that I have created a folder Hurricane IOTA, because this is how it is named on the Maxar website, even though the tile is actually from the data before the hurricane, the TIFF, sorry. And in this file, we have uploaded all the tiles, and you can see there are quite a lot of them. And now if I click on one of them, here is the actual TIFF that we have decided to name rgb.tiff. This final destination file actually now includes the RGB bands, and we now have to add it into our dashboard. Jumping back to our agenda to see what is next, we have actually created a personal bucket now. We have uploaded cog files to our S3 bucket, and now we have to create a collection and add those tiles to dashboard. To do this, go to dashboard. Of course, you need to have an account for this. We have free trial accounts available if you don't have one yet. Then you go to My Collections and you create a new collection. Just click on this green New Collection button, and then you give it any name that you like. For example, Maxar Data, Maxar Open Data. The type has to be BYOC, of course, and then the location needs to be the same location as your bucket is, the location of your bucket. You can simply check this by going there directly to your bucket, clicking Properties, and then you can simply just check so it is in Frankfurt EU Central 1 in case you forget. All right, so EU Frankfurt, this is correct. Then the bucket name, you can copy the bucket name inside. And here you could set the no data value, but we will do this later. Click Save Collection, and the collection has been created. You can see when the collection was created, you can see the collection ID. You can copy it clicking this button. So this is very handy because if you ever want to share the tiles that you upload to this collection, the tiles will not be actually uploaded to Sentinel Hub. Sentinel Hub will just be displaying them and reading them from your bucket. More on that in a second. However, if you ever want to share this collection, you just need to share this collection ID with others. Here is the bucket name, the bucket location, and all that. And down here, our band names are going to be configured once we tell Sentinel Hub where it should read the tiles from. So click on this tiles button and click add tile. We are now going to enter a tile. And to do this, it is recommended to just go back to your bucket, go back to objects, and then navigate to the final item. And then we can just copy everything from the folder. So we do not have to copy the actual bucket name because we already told Sentinel Hub that this collection is for this bucket. We just need everything else. We copy this and we paste it in. So now it is also recommended that you rename this last file to whatever you would like your band to be called. So what I am doing now, I have told Sentinel Hub that the name of the last TIFF should be what the bands are going to be called. More on that on a second, so that you will understand a bit better. When I click Save Tile, you will see that the tile is now actually ingesting. It is now in status waiting, and when it ingests, it will say ingested. The tiles can also fail, and then this status will say failed, and there are several reasons why this can happen. One of them is, for example, that the cog that you are trying to ingest is not actually compatible with Sentinel Hub. So all of these tiles that I have in this Maxar disaster data folder, all of them needed to be uploaded. And because this takes some time, and I just uploaded one of them now, and it's not even ingested yet. So what I had to do is upload each and every one of them. So I will now jump to the collection where they are already all inside. And here we are. Here we see all the tiles that we have on our bucket. If we click on next, you can see next, and you can see all of them. All right. So here is the sensing time. So the sensing time, you just need to, you can't read it actually from the Maxar tile or from the bucket. You need to know it. You need to know what your data is when you're ingesting it, and this sensing tile can be very helpful if you actually add it when you are creating a tile. All right, so another note, when you are creating tiles, in case you had your tiles in the root folder, so if I go back to objects directly, here, if you had them listed just like that down here, then you wouldn't actually have to import the folder, of course, but it would just be read from here. But note that if your tiles are not named in a way that it is very easy to read for Sentinel Hub, for example, let's jump to documentation and see a note about this. Ingesting the tiles here. If you have, for example, your tiles like this, you have two completely different tiles, and then bands, each one has its own bands. So in our case, our TIFF has bands already inside, but if you had it like this, then it would make sense for you to specify which part of this TIFF should be read as a band. And you do this like this, so you would just say band in parentheses, exactly the way as we did right now, because it is just more clear, and you will see what then happens. Let's jump back to our dashboard, go to details, and you can see the Sentinel Hub now read automatically from that final TIFF file, which we specified to be RGB 1, and we said, if you remember, band. So this is what it is reading now. RGB 1, 2, 3. So the first one is now corresponds to red, the second one to green, and the third one to blue. We can see that bit depth is 8, which is important, so that we will use this in an eval script, as already mentioned. And here you can see the source. The source is the source TIFF file that from which these bands have been extracted. And because our final TIFF file is called RGB, if we go back to navigate to it, see the RGB TIFF. This is why this says RGB. Then we also have band index here, and it just means that in case they are all from a single TIFF, there will be 1, 2, 3. So this one then includes 3 bands. So this might be a bit confusing. So this is why I have another example here. So this is an example for completely different data, just to prove a point. You can see the source here is, there are 2 different sources, and their band indices are completely different. So for this one, the BQA, this was a specific TIFF file. This one has 1 band available. That's why band index is 1, and it ends here at 1. And then these TIFF bands had 1, 2, 3, 4, 5 available. So this is why the band index starts at 1 again and then goes down to 5. So I hope this explains this, what the band index and source mean a little bit more. All right, so now we have a collection ID. We have the tiles ingested into our collection ID, and over here, we now just need to copy our collection ID, and we can immediately make a request to it to get an image. Before that, very important, you can rename your bands here. And of course, it would make sense for us to rename them to red, R as red, and then G as green, and then B as blue. Another thing I forgot to mention, you can always delete your tiles if you want, for example, if they fail or if you don't want them anymore. But note that when you delete a tile, it is not actually, it is only deleted from Sentinel Hub, but not from your bucket. But on the other hand, if you change the naming or if you delete a file on your bucket, you will have to re-ingest it into Sentinel Hub, because Sentinel Hub is only reading from your bucket. So the permissions that you gave to Sentinel Hub only allow it to read from your bucket, but do not allow Sentinel Hub to actually edit what is on your bucket or change anything on it. So you don't have to worry about safety or anything like that. All right, so now that we changed the naming of our bands, we can go to Request Builder and we can create a request and an eval script. I am now in Request Builder. It will also be linked from the description on YouTube. Going to Process, API, and then I will select the Bring Your Own cog option. And now it is very convenient because so I have accidentally named both of our collections the same. So this is why I will check that it's what this collection starts with is 590. 590, so this one is the correct one. You can conveniently select them from the drop-down menu. It lists all of your collections here. All right, so we now also need to be careful to set the correct time range, because our sensing time was in 2020, and it needs to include of course, the time in which was captured. Then we need to set the eval script, and this eval script is not going to work. First, the band names are wrong because we have our own band names now, and also this script works it is intended for values between 0 and 1. And we have our values in, as you remember, uint 8, so from 0 to 255. What we need to do is actually rewrite our eval script, and we will just return our bands as our G and B. But we also have to divide them with 255, as already mentioned, to get them back to values from 0 to 1, as the eval script expects. The last thing that we have to do is, of course, the bounding box. This bounding box is currently set to Rome, but we know that our TIFF is actually located in Nicaragua. So you can find the bounding box or the geometry of your tile in your dashboard. If you go to Tiles and then select any one of them, you will see the cover geometry over here. If you just copy this and go to Request Builder with it, click Parse, it will set, and you can see that this is it is indeed in the right spot. And then now if we click Send Request, hopefully we should get an image. And there we go. So this is an image of this specific tile, not of the whole TIFF, but just the tile where we copied this geometry in. And you can see that on the borders here, we have the black no data values. Now what we could do, we could just, if we write here the data mask, this is not actually going to remove these tiles because we haven't told Sentinel Hub what no data values are. So this is why we're going to go back to our dashboard, to details, and we will set the no data value for our 3 RGB bands to be 0. We learned that it is 0 from QGIS before by inspecting the no data pixels for values. Now that we have it set up, and we also have data masks inside our script, which says that any pixels that are flagged as no data, which we have now told Sentinel Hub to be all pixels with value 0, are going to be transparent. This is because the 4th channel in the eval script is reserved for transparency. If I click send request now, we can now see that the black pixels have disappeared. What this means is that black pixels which are no data have become transparent. If you still see the no data pixels colored in black here, make sure that you do not have by accident the JPEG format on, but instead have PNG or TIFF, because JPEG does not support transparency. And also note that BYOC collection info is cached for 30 seconds. So if you change something on collection like no data, like we changed, you may need to wait for this long to get the latest state. All right, so another thing about covered geometries. So as you saw, we just displayed one tile here, but if you wanted to display the whole TIFF, you would need the geometry for the whole TIFF. You can either create or you can read in our documentation how to make covered geometries. So just a second on that later. Over here, I have already this covered geometry in, and I have the eval script set. And now if I send this, I will hopefully get an image of the whole TIFF file, which is going to mosaic together all of my tiles like this. So the covered geometry, the note on covered geometry, you can find more about this in our documentation, a note about covered geometry. So it is important for you to set it in case you have many tiles overlapping, which we do not have at this point, and you can read all about the commands that create them, easier and more complex examples in our documentation. Where you, the place where you will edit them, of course, is in the covered geometry editor in dashboard. All right, so now we have actual requests that we can download in Request Builder. The last thing that we want to do, if we jump back to our, to check what is the next thing. So we have now, we created a collection and we added tiles in dashboard. And then we created a process API request to our collection. Now we will create a configuration and we will visualize this data in your browser and then talk about QGIS for a second. To visualize this in your browser or in QGIS, we need to set the configuration. So we will go back to dashboard and to configuration utility. Just another note about collections. You can filter your collections. You can select BYOC, and then it will display all of your BYOC collections in case you have a lot of them. Jumping to configuration utility, click on new configuration, and then give it a name. For example, IOTA Nicaragua, and click create configuration. And now we will create a true color layer. True color, of course, we need to now set the source to be BYOC, bring your own cog, collection type BYOC, and now we have to select a collection, and we can just set it from the drop-down menu here, or you can always copy it from the collections like this. So this one is correct. You can just copy it, go back, Hurricane IOTA Nicaragua, like that. And I have to redo this because I exited, but no problem with that. It is just takes a second. Paste it in. There we go. And now we just need an eval script. And we already wrote the eval script in our request builder before. So we can just copy it, paste it in, and click save. All right, now if you go to, we can go directly to your browser and find configuration here under Teams. But you can also just click open in your browser for convenience, which is going to open this specific configuration in your browser immediately. You can see it up here. We have to select it. And we also have to consider the sensing time, which was in 2020, in April 2020. So let's say, for example, March 2020. And of course, we need to navigate to an approximate location of Nicaragua. Okay, and now if we click search, we are going to see all of the tiles displayed. So hopefully now you can see what retiling did. You can see that it created 3 different columns of 13 rows. So the third one is hidden right here. It's a bit smaller. And this is why we had 3 times 13 tiles. So we had tile 1, 1, tile 1, 2, tile 1, 3, 1, 2, 3, tile 2, 1, tile 2, 1, tile 2, 3. And we can now visualize this by just clicking visualize, and then actually the whole TIFF file is going to be displayed, mosaic from all of those tiles. And we can now zoom in, we can do analysis on this, we can download it, do anything that your browser allows you to do. A very important note, once you import any of your data into Sentinel Hub, you can use so many different functionalities on it. You can use it in your browser, which offers so many, for example, 3D functionality, time lapses, and many, many more. You can use data fusion. You can, for example, use statistical API or batch API or anything that Sentinel Hub offers. And that's just really, really cool that you can use your data like that. Now, the last note that I want to make is, of course, we shouldn't forget about the QGIS. So in QGIS, it is very easy to import any data from your dashboard. You just need to have a configuration set up, and then you need to have this Sentinel Hub plugin. It is very simple. You just go to plugins and install the plugin, and then when you have it, you just log in with your credentials, and then you have the create here where you select your configuration and layer, click create, and instantly it will show on the map. You can then also download this data. I will not go into too many details here because you can always watch the webinar on OGC and QGIS integration, which will also be linked in the video description. Now, just the final note that I would like to make is that all of this process that we made can be done in different ways. We just did it using the user interface of dashboard, but it can also be done using our API directly. So if we go to the documentation and you go to BYOC API examples, you will find Python requests here for creating a collection, creating tiles, so many different things. So this is another way that you can do it. And also very important that I would like to mention, we are also quite proud of our BYOC tool, which you can find on our GitHub. If you go to github.com Sentinel Hub and you navigate down, you are going to find the BYOC tool. Here it is. And you can read all about it here. And what this does is actually just another way to get your data into Sentinel Hub, and it converts your files to COG. It uploads them to AWS S3 bucket, and then it also creates tiles for you. It is quite powerful, and you can modify it and specify the parameters to fit your needs. All right, this is it for this webinar. Please ask away if you have any questions, and I hope to see you in the next webinar. Thank you.
Thank you, Munia. So we can proceed with your questions. We received one question by Cremina. Can Sentinel Hub ingest from a place different from AWS? If so, what is required to pass to the API?
So we do support some other storage options. So you can ingest data from DIAS platforms. So those are GeoDIAS, Mundi, and CodeE. And for example, to ingest data from GeoDIAS, you would create a bucket in the similar way as on AWS. You would set the same policy as on AWS that would allow Sentinel Hub to access your data. Currently, we don't have this bucket configuration documented for DIASes, but we plan to do this.
Thank you, Tomi. If anyone else would like to ask something, you can also raise your hand and I can unmute you, or you still have time to write your question in the chat. And in the meantime, Munia can also show some additional links So we would like to invite you, if you don't have already a Sentinel Hub account, you can create a 30-day trial account. Here we share the link. If you will need more processing units, then the trial actually provides for your bring your own data API testing. Just contact us and we will extend the limited units on your accounts. I would also like to mention that if you're conducting research or you're in a pre-commercial exploitation phase, you can use the opportunity to apply for ESA-sponsored accounts and access to high-resolution commercial data. This is all available through the Network of Resources program, and for more information, you can also see the provided link. So there is another question regarding the citation. If you use the images for research, so any kind of usage for research needs to be cited properly. Monia, you can show it on our webpage. Among the frequently asked questions, we have the answer to this one.
So if you just go to develop an AFQ, you can find the information here, and also terms of service up here.
So if we don't have any other questions, I would still invite you to freely use our forum, where you can ask us anything else related to the Sentinel Hub services. And we invite you to stay tuned and follow us on social media for future webinars. And if you're not connected yet, we will provide you with the links in our next email along with the recording. Thank you, everyone, and we can conclude our webinar now. See you the next time.